So if we're doing a population proportion, and this gets into 22, you know, the formula is much the same, but a little bit different. So we gotta do a few more things. But again, we take a look at 21, and we don't have standard deviation in this case. Okay, so we've got to do some other things, right? It says the estimate of the population proportion is to be within plus or minus 0.05. So my error size, right, is 0.05. Where was I? It was plus with a 95% confidence level, right? And so I've just put in my z, you know, or 1.96. I'm sorry. Your guys is 99%. Remember that, so it's going to be different, right? But that's a number you should kind of remember too by this point in time. And then it goes on to say that the best estimate of the population proportion is 15% or 0.15. How large a sample is required. So here's our formula that we have for that, like we said on page 303. Just n is equal to the proportion times 1 minus the proportion times, okay, z, our z over our error squared. Okay, so we can do, again, I break it down. So I'll do the proportion times 1 minus the proportion here is equal to my proportion, or my pi, times 1 minus pi. Right, and that equals 0.1275, and then I'll probably do my z divided by my e here. Okay, I do the whole thing, I guess, and then square it. So this is equal to my z. Oops, I'm going to probably need a parentheses here. So z divided by my e, parentheses, and I'm going to square that. Okay, so my little 10 into the second, and there we go. 1543, and then, you know, having nothing there is the same as multiplying that, and so really I just need to multiply those two, so it's just equal to times this. So I need a sample size of 195.9. Again, I'd round up, and I would say that my sample size should be 196. Okay, there you have it. Again, relatively simple.